Suppose we want to solve the equation cos 2 theta equals minus 0.5, where theta is an angle between 0 and 360 degrees. Well, you go to your calculator and you plug in the inverse cos or arc cos of minus 0.5, and your calculator gives you this answer, 120 degrees. Now that's 2 theta, not theta. So let's just see this on the unit circle. Now I'm saying that this angle here is 2 theta. So we know that on the unit circle the coordinates of a point are given by the cos and sine of this angle. So if this angle is 2 theta, then the coordinates are cos 2 theta, sine 2 theta. The x value of this point is minus 0.5. Now we need to get other values for 2 theta, or well, maybe there's just one other value. Actually there's more, as I'll explain later, but let's get one more value of 2 theta such that the cos of 2 theta is minus 0.5. Well, that's quite easy to do here. We can just move this so that the x value of the point is minus 0.5. Here it is. So we can see that for an angle of 240 degrees, the cos of it is minus 0.5. We're not interested in the sine. The y value is the sine. So when you're doing this question, you need to look for the quadrants that give a negative value for the cos function. And those quadrants are the s and t quadrants. So in the s and t quadrants, only the sine function is positive here, so the cos is negative. And in the t quadrant, only the tan function is positive, so the cos function is negative here. So these are the two quadrants that give negative values for the cos function. The cos function is positive in these two. So you know that we're dealing with an angle between 90 and 180 degrees and an angle between 180 degrees and 270 degrees. So if we reflect this point through the x-axis, we will get the required point whose x value is also minus 0.5. So we need an angle measured anti-clockwise from the positive x-axis to a line joining this point to the origin. So we need to consider the image of this angle in here. Well, to find this angle, we take 120 from 180 degrees, and we get 60 degrees. So we have 60 degree angle in here. We reflect that angle through the x-axis. So in this case, we can see that our reference angle is 60 degrees. So what we need to do is add 180 degrees onto 60 degrees to get our answer, 240 degrees. So we found two values for 2 theta, and of course to find theta then we just divide across by 2. So theta must be either 60 degrees or 120 degrees. However, we can find more solutions. Theta has to be an angle between 0 and 360 degrees. We can actually get more values for 2 theta, so that we find that theta is an angle between 0 and 360 degrees. You see, we can add 360 degrees onto an angle, and that won't affect the value of the cos function. So if I add 360 degrees onto 120, I'll get an angle whose cos is also minus 0.5. So let's look at this picture. Here we have an angle of 120 degrees. If I add 360 degrees onto this angle, all I'm doing is going back around to the same position. In that case, we're talking about an angle like this. So we're measuring anti-clockwise from the positive x-axis. So we're going to get an angle that's more than 360 degrees, more than one revolution. If we do that, we get an angle of 480 degrees. So here is another possible value for 2 theta. Now 480 degrees might be outside this range here. This range is from 0 to 360. But the thing is, when we're finding theta, we have to divide this by 2. So if 2 theta is 480 degrees, it means that theta is 480 divided by 2, which is 240 degrees. And 240 degrees is within this range. So now we found a third solution to this equation. And of course it's easy to check it by going to your calculator. We multiply 240 by 2 and that'll give us 480, and if we get the cos of 480 we should get minus 0.5. Of course I can do the same thing to 240 degrees. I can add 360 onto 240 degrees and divide by 2. So let's take a look at that angle. So here it is, 360 plus 240. The cos of that angle will also be minus 0.5. If we do that we get 600 degrees. So we could call the coordinates of this point cos 600 comma sine 600, and it's the same as cos 240 comma sine 240. So now we get yet another solution to the equation. If 2 theta is 300 degrees, then theta must be 150 degrees. You might think that we could keep going like this. You could actually keep adding 360 degrees onto the values of 2 theta we have here, and then dividing by 2. But the thing is, if we keep going, we will get a value of theta that's outside this range here. Theta has to lie between 0 and 360 degrees. So for example, if I add 360 onto 120 degrees twice, well, the first time we did it we got 480 degrees. If we do it again, we 480 plus 360 is 840. Now, that's a solution. The cos of 840 should give minus 0.5. Let's check that. There we have it. But the problem with 840, if 2 theta is 840, then theta is got by dividing this by 2. We get an angle of 420 degrees, which is outside this range here. So we ignore those solutions. So this is as far as we go. We have an infinite number of solutions, but we want our solutions to be between 0 and 360 degrees. So we have 4 solutions that are valid in this case.